GeopByte.
Similarly, let us take the another important problem. Okay, look at the screen. It is asking like this. The density of material in CGS system of units is 4 grams per cm cube in a system of units in which unit of length is 10 centimeters and unit of mass is 100 grams. The value of density of material will be, okay, as you know, the product of numerical value of a physical quantity and its unit is always remaining constant. This part already we have clearly discussed. The product of the numerical value of a physical quantity and its unit is remaining constant. What it means? N1 U1 is equal to N2 U2. Here N1 U1 given 4 grams per cm cube is equal to N2. U2 must be with the density unit, that is equal to mass by L cube, right? Volume. Now it is 4 grams per cm cube is equal to N2 into mass is given 100 grams divided by 10 power 3. From this I can write that N2 equal to 4 into 10 power 3 divided by 100 is equal to 4000 divided by 100 is equal to 40. That is the answer. Look at the option B. Option B is absolutely correct. Okay. Similarly, let us take the another important problem. Look at this problem. It is asking like this. The dimension of half epsilon naught e square, where epsilon naught is the permittivity of free space and E be the capital E be the electric field. Okay. It is asking the dimensional formula. As you know, dimension of dimension of half epsilon naught e square means dimension of dimension of epsilon naught e square. Okay, it is equal to, epsilon naught dimensional formula m power minus 1 L power minus 3 p power 4 a power 2 multiplied by E. The electric field E dimensional formula is M L P power minus 3 A power minus 1. It is square, E square. It is M power minus 1, L power minus 3, P power 4, A power 2 into M power 2, L power 2, P power minus 6, A power minus 2. Now you simplify. This is equal to M power 1, L power minus 1, T power 4 into T power minus 6, T power minus 2, here A power 0, A power 0. This is the dimensional formula for the quantity epsilon naught into E square. So look at the option B, M L power minus 1, P power minus 2. Option B is absolutely correct. Okay, na? Similarly, let us take the another important problem. Look at this problem. It is asking like this. If the dimensions of a physical quantity are given by m power a, L power b, T power c, then what is that physical quantity? Okay. For that, option A is given for pressure. As you know, pressure pressure equal to force per unit area. Unit area. Pressure dimensional formula. pressure dimensional formula, force dimensional formula, MLT power minus 2 divided by area L power 2. Simplify it. It is equal to M L power minus 1 T power minus 2. Here A equal to, this is given as M power A, L power B, T power C. Therefore, let me write it clearly. Therefore, from this I can write A equal to 1, A equal to 1, comma L equal to minus 1, not L, B equal to minus 1, B equal to minus 1, and C equal to minus 2. A equal to 1, B equal to minus 1, C equal to minus 2. Option A itself is absolutely correct. Whereas for velocity, you know velocity. Velocity dimensional formula is m power 0, L, T power minus 1. Here A equal to 0, B equal to 1, and C equal to minus 1. Right? So A equal to 1, not correct. It is not correct. Similarly, look at the another quantity, acceleration. Acceleration. Dim acceleration dimensional formula is m power 0, L power 1, T power minus 2. From this I can say that A equal to 0, B equal to 1, T equal to minus 2. A equal to 0, not 1. C also not correct. Now look at the force. Look at the force. Force dimensional formula is M L T power minus 2, L power 1, M power 1. From this I can say that A equal to 1, B equal to, B also equal to 1, and C equal to minus 2. A, B 1, C equal to minus 2. A equal to 0, no. Option D also not correct. Option A is correct. Okay, understood clearly? Only, right, option A is matching the given power factors. Okay, similarly, look at the another important question. So it is also similar to, it is also similar to previous problem, right? It is on. So from this you can conclude that the questions are repeating in the NEET also. The same question. Okay. Similarly, let us take the another important problem. It is asking like this. Which two of the following five physical parameters have the same dimensions among the given quantities? Which one is having the same dimensional formula? First one is energy density. As you know, energy density means energy by volume. Now, energy density dimensional formula, energy density dimensional formula equal to energy m L power 2 T power minus 2 divided by L power 3. L power 3, simplify it. For getting m power 1, L power minus 1, T power minus 2. That is the dimension for the energy density. Now come to the refractive index. Refractive index and dielectric constant. These two are not having any dimensional formula, right? Let me write that point. The refractive index, and dielectric constant, these two are having no dimensions. No dimensions. Now look at the Young's modulus. Young's modulus unit, right, is equal to stress unit only. Young's modulus Young's modulus is equal to stress by strain. Stress by strain. As you know, strain has no units. No units. Therefore, Young's modulus unit equal to stress unit. For Young's modulus dimensional formula equal to stress dimensional formula. Right? Stress equal to what? Force per unit area. Right? It is equal to force dimensional formula divided by area dimensional formula. Force M L T power minus 2 divided by L power 2. Simplified for getting M power 1, L power minus 1, T power minus 2. This is the Young's modulus dimensional formula. M power 1, L power minus 1, T power minus 2. Look at the energy density M power 1, L power minus 1, T power minus 2. Therefore, the energy density and Young's modulus both are maintaining the same dimensional formula. Therefore, option C can be selected. Okay. So, if you ask me to decide the dimensional formula for magnetic field, for magnetic field, for magnetic field equal to what? Force dividing by current multiplied by length. Okay. Now let us read the dimensional formula. M L T power minus 2 divided by I ampere. L. L cancelled. Finally it is M power 1, L power 0, P power minus 2, A power minus 1. This is the dimensional formula for magnetic field. It is other than both Young's modulus and the energy density. Anyhow, option C is absolutely correct. Okay, energy density and Young's modulus both are maintaining the same dimensional formula. Okay, are you following clearly? Yes.
GeopByte.